In today's lesson, we're not going to learn anything new. We're just going to start playing with some of the linear relations we've been looking at. So gathering information, making equations, figuring out different things about our patterns. And our big idea so far is every time we have an equation, it should be in the form y equals b plus mx, or mx plus b means the same thing, where b is our initial value, m is our rate, our multiplier. And we always need to have a y and an x, and we need to know what they stand for. So we always want to define our variables. I'm going to jump right into some examples today. So the mass, m grams, of the box of box of crackers can be related to the number of crackers in the box. That's filled in the table below. So it seems to me like we have some sort of pattern here. Okay, our mass, it starts at no crackers, already weighs 55. That must be our initial value. Probably how much the box weighs all by itself. And then it seems like every time we add 5 crackers, it goes up 30. We add 5 crackers, it goes up 30. If we add 5 crackers, it must go up 30, right? That's the pattern. So we can figure out the next one pretty easily. But if we look at the next one, it's not going up 5 crackers anymore. It only went up 3. So it can't go up 30, some sort of other pattern. So if I want to figure out the missing value, it makes sense to me to figure out the equation. If I have an equation, I can figure out any value I want in the pattern. Well, what do I need for an equation? I need an initial value, which I already have, and I need a rate. Let's find a rate. The rate is the difference between any 2 points. Well, we just figured out the pattern, right? We were going up 30 for every 5 crackers. 30 what? Grams, 5 crackers. Or in other words, 6 grams per cracker. Okay, we got ourselves an equation. Okay, our equation is y equals, started at 55, and went up 6 grams for every cracker. Now I said y and x. Really, I guess it shouldn't be y and x, because that's not the letters they used. They used m for the mass and n for the crackers. But it's the same idea, right? Okay, I want 18 crackers. Where's the crackers in this equation? That's the n. Okay, we'll take out our handy calculators, because we've got to do bed mass here. 55 plus whatever 6 times 18 is. It's 108, which gives me 163. Yeah, we could figure it out using our equation. Similarly, if I know the mass is 355, can I work backwards and get how many crackers? Absolutely. Okay, our same equation, m equals 55 plus 6n. But what do we know this time? We know the mass is 355. So I'm going to put that in over here for m, and I'm going to solve for n. So I'll just subtract numbers on one side, letters on the other. Okay, collect our like terms. We want to know 1n, so n must be 50 crackers. Okay, if we don't know parts of a pattern, we can always use an equation to figure them out. Only challenge is building that equation. Okay, so let's take a look at a second example. A hot air balloon has developed a steady leak and begins to descend, so it's going down. Its height at certain points has been measured. After 2 minutes, it's at a height of 320. After 12 minutes, 120. Can we graph this information? So they've given us a grid with some numbers on it. We have to figure out which one is which. So it makes sense to me, look at the information that we got, that the minutes, number of minutes, would be across the bottom. Number of minutes. I've already started my pattern, so I just got to finish the pattern. Going by 2s each time. And 20 minutes should be enough. Up the side, I think that's our height. The pattern's going by 40s. So we'll add a few more of these in here. That should probably be enough right there. What do we know? Back up here they told us 2 minutes, it was 320. So 2 minutes, There's our balloon at 320. At 12 minutes, we were at 120. 12 and 120. And that's all the information they gave us, 2 dots worth. Okay, is this relation partial or direct? Well, what else do they know about this relationship? We know it's a linear relation. It means it's a pattern, right? Which means if I were to take a ruler and connect my dots, because we know it's following a pattern, I can actually figure out if it's partial or direct by looking at the line. What do we notice about the line? It has an initial value of 360. That means it's got to be partial. Not an initial value of 0. It started up in the air, which kind of makes sense, right? Oops, has an initial value. In fact, we know what it is already. And which is actually what part C is, right? What was the height of the balloon before it started leaking? Well, we just figured out it was 360. It always makes sense to extend your line so it actually hits the axis, because that's your initial value. Kind of an important point. Okay, how high is the balloon at 8 minutes? Well, that's what I could find in my graph. Here's 8 minutes. If I go up to the line, it's right about there. 200 meters. E. At what rate? Okay, rates. We like rates. They're always the same thing. And our triangle. I got a whole bunch of nice points. Let's start with the easiest one, 360, and go down to this point. So down 360 to 200. That's down 160. And how much did we go over? That took us 8 minutes. So it's down, so it's a negative. It's 160 meters. That's 8 minutes. If I divide it, I get 20 meters per minute. Make sure it's negative, it's going down. Okay, our typical question. Oh, no equation. Just want to know when the ball hit the balloon hit the ground. Which again is something I can find on my diagram. It looks like it hits the ground right about there. So for part F, 18 minutes. Okay, it didn't ask us for the equation this time. We probably could make the equation. We have the rate, we have the initial value, we know what the letters stand for. Just didn't have to do it this time. Okay, that's a good graphing question there. Okay, we'll try one more. Okay, last example. We got Jocelyn. She's selling newspaper ads. Her earnings, E, are given by this equation. So earnings equals 5 times A. A is the number of ads she sells. Let's make a table of values from daily sales up to 60 ads, going by tens, and then graphing it. Okay, that's part A. Number of ads. Earnings. Okay, I always want to start at 0. We're supposed to go by tens. 10, 20, 30, 40, 50. How high do they want us to go? Up by 60s. Okay, how do we get the earnings that goes along with it? Well, let's use our equation. Okay. If she sells 0 ads, we can do 5 times 0 plus 50. Well, we know 5 times 0 is really nothing, so we're left with the 50. In other words, our initial value. Okay. What if she sells 10 ads? Well, that's going to be 5 times 10 plus 50, which is 50 plus 50, which makes 100. Yeah, how about 20 ads? 5 times 20 plus 50. Well, that's 100 plus 50. That makes 150. There seems to be a pattern here. Kind of our big idea, right? It's going up by 50 each time. So we know what the next one's going to be. And the next one. And the next one. And the next one. Okay, let's graph it. Number of ads. They already started the pattern for us. 5, 10, 15, 20, 30, 35, 40, 45, 50, 55, 60, just what they wanted. And up the side, 150, 200, 250, 300, 350, 400, and this is our earnings. Okay, and we have some dots. We know that if they didn't sell any, they still get paid $50, our initial value. 10 was 100, 20 was 150, 30 was 200, 350, no, sorry, 250, 300, and 350. Oh, that was too high. That's 400. 350 right there. Connect them all together. And there's our pattern. Okay. How much will she earn on a really good day where she sells 100 ads? Well, I can't find that one on my graph, but we don't really need a graph if we have an equation. Right? She sells 100 ads. And do our bed mass. And she's going to make $550. The same way we found all the other values in the equation, just skipping over a bunch of them. Okay, there's a change in management. Jocelyn only gets paid if she sells. However, she gets $10 for every ad she sells. Can we graph her earnings up to 60 ads? Well, so let's do this. Let's take our table and we'll add a column to it. I'm just going to turn this back into an E here. That was that question. Let's add a new column. So what's happening this time? She's getting $10 for every ad she sells. So if she sells no ads, how much money does she get paid? Nothing. If she sells 10 at $10 each, well, 10 times 10 makes 100. 20 ads, she'll get 200, right? Just times it by 10. 30 is 300, and we're following our pattern. And there we go. Let's graph that one. 0, 0. No money for no ads. But she sells 10, she gets 100 bucks. 20, 200. 30, 300. 40, 400, and so on. Okay, if we draw that line, looks like that. Okay, we graph the sales. Yep. How is the graph different from the graph in part B? Well, if I was describing it, I would say it starts lower. We're starting at 0 this time instead of 50. And to me, it looks steeper. It's going up at a sharper angle, which makes sense and getting paid at a bigger rate. And the bigger the rate, the steeper the line. Okay, last part, write the new equation. We can do that. Okay, her earnings are $10 for every ad. That's what we did to make the table, right? Same idea, just write it as an equation. Okay, that's it for that lesson. Try the sheet. Okay, we're just playing with linear relations today. Nothing new, just different formats of things we can do with them. Tables, graphs, equations.